This video is on inscribed angles of a circle. The first thing we need to review is central angles. Some things to remember about central angles would be on the inside of the circle is that the vertex is at the center of the circle. So on this picture, one example of a central angle would be angle ABC. See how it meets right here at the center of the circle? That's a central angle. If you also remember, the central angle equals the measurement of the arc. So if angle ABC happened to be 45 degrees, then arc AC would also be 45 degrees. Keeping in mind, if you use 3 letters, that means that's a major arc. So that degree is going to be greater than 180 degrees. 2 letters is less than 180 degrees. So AC, 45 degrees would be a minor arc. So the new types of angles for today are called inscribed angles. So if you just glance at these two pictures, you notice that where the angle is actually created is at the edge of the circle, and it doesn't come from the center. That's what an inscribed angle is. The other vocabulary word that you should be familiar with is called a chord. Sometimes students mix up these segments and they think that they're the diameter. But the diameter has to go through the center of the circle, and a chord is a segment whose endpoints are on the circle. So you can see here we've got endpoints on the circle. So looking at this picture, AC is a chord because it doesn't go through the center of the circle. Its endpoints are still on the edge of the circle, but it doesn't go through the center. So these are chords. Same thing on this one. AC would be considered a chord, and AB would be a chord. The rule for inscribed angles is different from central angles. A central angle measurement equals the arc, whereas if it's an inscribed angle, it's 2 times the angle equals the arc, or 1/2 the angle equals the arc. So for example, if I have angle CAB, and this measurement right here is 30 degrees, my inscribed angle is 30, which means my arc would be 2 times that angle measurement, so the arc would be 60 degrees. Notice over here it says angle A is the inscribed angle. So here's A right here, or angle CAB. Then you'll also see some vocabulary that talks about an intercepted arc, which is basically the CB arc right here. So this is your inscribed angle, this is your intercepted arc. Looking at this picture, if I were to tell you that arc CB has a measurement of 40, then angle CAB in here would be half that, which would be 20 degrees. Here are some examples of some of the questions. I put a circle on here so you could see the difference between the central angle and the inscribed angles. So looking at this first one, this is an example like we did in the previous work with circles. This Y comes from an angle that's at the center. So if this arc right here is 90 degrees, that means Y has to be 90 degrees as well. And same thing on this one. This angle is listed as 100 degrees, which means its arc also has to be 100 degrees because the center is at the center of the circle. So these are central angles. The second picture right here, this Y is an inscribed angle, and this out here is an intercepted arc. Well, notice this one's a little different because we don't know these two, but there are some things that we do know. We know that there has to be 360 degrees in this circle. So if I take 360 and subtract these two, the 80 and the 110, so if I subtract 190 from 360, that leaves me with 170 degrees. So this arc right here has to be 170 degrees. And the inscribed angle across from that has to be half of that. So half of 170 is 85. So this y value would have to be 85. Looking at the third example here, this 41 degrees comes from an inscribed angle, which means this arc across from it has to be double that value. So double 41 would be 82. And this one, I gave you the opposite. So I gave you the intercepted arc, which is 92. And if I take half that, it gives me 46. The last theorem for inscribed angles is if two inscribed angles make the same arc, then they have to be congruent. So if you notice in this picture, there's two triangles in here, but these are also inscribed angles. So if you notice, I highlighted this one in red. This x corresponds to this intercepted arc here. So if its intercepted arc is 120, then x has to be half of that, which is 60. So we could write 60 in here. So x equals 60. And if I also look at this angle to the right, right here, it's the same arc. And it also has to be, this y value also has to be 60 because they share the same arc. So y also equals 60. Another theorem, this theorem states that if a quadrilateral is inscribed in a circle, that means inside a circle, then opposite angles are supplementary. So here we have a circle, and inside you'll see a quadrilateral. If you can match up the opposite angles, these have to be supplementary. So if this one is 50 and I take 180 minus 50, that means that x here would have to be 130. Okay, and I got that by taking 180 minus 50 equals 130. Equals x. If this is 88, then we can take 180 minus 88, and that would equal 92. So x would be 130 and y would be 92. And on this next example, here for our second example, its intercepted arc is 40, we can see here. So that means that x has to be half of that, so x is equal to 20. Again, there's 360 degrees in a circle, so if I know there's 360 and I know this arc is 40, then I can take 360 minus my 40, and that leaves me with 320. And then these arcs here are marked congruent, so if I take 360 and divide it by 2, that leaves me with 160. So I know that each of these sides would be 160 since they're congruent. Looking at this next example, I'm going to start this one with this inscribed angle starting here with the V all the way over to the 75. So you can see that highlighted in red, degree angle. So thinking of this inscribed angle, this is the intercepted arc going from this point back to where we started. So here's our inscribed angle and here's our intercepting arc. So if this is 100, that means its arc has to be double that. So 2 times 100 would be 200, which means this whole arc has to be 200. Well, this much is already 150. So if I do 200 minus 150, that leaves me with 50 degrees for my x. So x equals 50. The other thing I can do is I can look at the fact that inside my circle I have a quadrilateral. which means opposite angles have to be supplementary. So if this is 100 and W is opposite of it, that means that W has to be 80, because they have to add together to make 180. And here's 75, and V is the opposite angle of that. So those two have to add up to be 180. So 180 minus 75 is 105. So V equals 105. So if I look at this inscribed angle here from the W all the way over to the 100-degree angle and its arc, so if we follow from here all the way back around, if angle V is 105, this arc on the opposite side has to be double that. So if I double 105, I get 210. So I know for the entire arc, it equals 210. So this arc right here has to be 210, and if this is already 150 of that, I can go 210 minus 150, and that gives me 60. So I know that my Z value here has to equal 60. So Z equals 60. So now I know all these arcs. I've got a 50, and a 150, and now I know I have a 60, and I know there has to be 360 degrees in a circle, so if I subtract the 50 and 150 and 60 from 360, that's going to leave me with Y, which is going to be 100. So Y equals 100. So we took the 60, 150, and 50 and subtracted those from the 360 to give us what our Y value was, which is 100. So all of these on the outside should add up to be 360, which they do. If you take your 150 plus 50, it's 200, 60, and then 360. And inside here, we have a quadrilateral, and if you remember, all quadrilaterals have to be 360 degrees. So inside of your quadrilateral also would have to be 360 degrees. And we have 105 plus 75 is 180, and 100 plus 80 is 180. So we have 360 degrees inside our quadrilateral as well as outside of our circle.